Hi students, welcome to Max Point of View. Today we are going to understand the concept of sign convention and lens formula. This concept is very easy to understand. If you have the knowledge which I am going to teach, then you can solve any numerical. Okay, what we are going to learn today? Just when to put minus, when to put plus for different terms. That's it. If you know that, that is based on the concept. If you know this concept, aramse we can solve all the numericals. So without wasting any time, we'll start with our concept. First, we will learn the sign convention of lenses and their procedure. See, procedure remains the same for both lenses and mirrors. First, we will talk about lenses. At the end, I'll teach you the complete sign convention of mirrors. Now we'll learn the very easy concept, that is nothing but sign convention. So before going to the sign convention, we need to understand the terms. See, U, object distance. U means what? Object distance. So what do you mean by object distance? See, listen, object distance, image distance and focal length, these all the three are distances. All the three are distances. These two are heights. Height is different and distance are different. Okay, distance means what? Distance from the object to the optic center. See, all the distances are calculated, all the three, U, V, F, only these three, okay, are calculated from the optic center. See, assume this is the object. Okay, from object to optic center it is 10 centimeter. Okay, from object to optic center it is 10 centimeter, but the distances are not calculated from the object to optic center. Completely wrong. It is calculated from the optic center to object. Oh, in both the ways we are going to get 10 centimeters only, right? But the plus or minus sign will change. That is why all the distance you have to calculate it from the optic center. Assume you have an image here, somewhere here. Okay, from here to here, what is the distance? You should not calculate from the image to optic center. Okay, from the object to optic center you should calculate. You should always calculate from the optic center to the object, from the optic center to the image. Okay, all the three, U, V, F, all these three should start from optic center. This is the basic. Next, image height, object height. See, they can give you different names also. Okay, image size is also same as image height. Then length of the image is nothing but height of the image. Length of the image is nothing but height of the image. The same thing goes for object height also. They can use object height, they can ask you object size, find the object size. Then they may ask you find the length of the object. If they ask you length of the object or length of the image, they are talking about height of the object or height of the image. Keep this in mind. So if you know these things, and one more thing, height of the image and height of the object will not be calculated from the optic center. It is calculated from the principal axis. See, this complete center line, okay, is principal axis. Principal axis is not only on the left side, it is also on the right side. The complete center line is considered as principal axis. So how we can use principal axis to find it? Assume this is the object. I told you this is the object. From the principal axis till this part, what is the height? Okay, what is the height? That is this is object, right? This will be object height. Object height is denoted as O. Okay, object height is denoted as O. Next, assume you're going to get the image somewhere here or somewhere here, anywhere. Okay, if you get the image here, this is the height of the image. This is the object you kept in front of a lens, any lens. Don't worry about the lens. Okay, somewhere here when you are going to write the plus or minus, then the lens matters. But now for whatever the lens it is, okay, all the distances when from where to where we have to calculate, that remains same for both the lenses. Now listen, assume this is the object. If you keep in front of this lens, any lens, okay, now you will get one image in front of it only. So what is the image height? Image height is nothing but from the principal axis till its top. So this is how we are going to find the image height. Okay, assume the image is here. For now, assume this is the object and this is the image. Okay, see, first thing, when the object is denoted as AB, okay, this image is inverted, right? It is upside down, inverted. So if this is AB, where is A? At the top, correct? This, assume this is the head and this is the tail. A is at the head, so here A you should write and here B you should write. But what is the difference between these two? No difference, right? So that's why we'll denote it as A dash and B dash. Dash represents it's an image, without dash it represents object. Now, so this is the object and this is the image. Now height of the image will not be calculated from the optic center. Okay, see, from optic center to the image, it is image distance, not image height. Image height is always calculated from the principal axis till its top head. That's it. So if you know these many things, we can aramse learn the sign convention. The terms are very much important. Now we can aramse learn the sign convention, because anyhow we got to know the terms. If you know this much, that is enough to learn the complete sign convention. Okay, listen. So here anything is in this direction, okay, whether this side or that side, okay, it is always considered as positive. Okay, this is also positive, this is also positive. Okay, see, how can we say this is in this direction or this direction? All the distances are calculated from what? Optic center, correct? So all the three are calculated from the optic center. Now if you get the image here, how will you calculate the image distance? That is nothing but V from the optic center to the image, that is in this direction, correct? So it will become positive. Anything which is in this direction, okay, whether this side or that side, it is considered as negative. I'll give you one example. Object, where is the object is placed? Here. Object is always considered, it is placed on the left side of the lens, whether it is convex lens or concave lens. Okay, this sign convention works for both. Okay, listen. Object is here. What is object distance? From the optic center to the object. It is in this direction, right? So it is always considered as negative. So in both the lenses, okay, U is always negative. Why? Because U we are going to place it here only, in front of the lens. Whether it is convex or concave, we are going to place it here only. So always U means object distance. Object distance is from the optic center to the object. It is in this direction, so it is always considered as negative. Anything is in that direction, okay, it is always considered as positive. I'll give you some example, then you will understand. Now listen. Next, anything in upward direction, it is always considered as positive. Anything it is in upward direction, it is always considered as positive. Then anything in downward direction, okay, it is always considered as negative. So just remember all these values. I'll keep on giving the examples, then you will understand. Anything towards the right, okay, it is positive. Anything towards left, it is negative. Okay, anything which is up, it is positive. Anything which is down, it is negative. Just remember this. Okay, then I'll keep on giving the examples, then you will understand properly. Okay, now we have kept an object. Okay, because of the object, okay, assume this is convex lens. Convex lens, 90% of the time you will get real and inverted, but 10% of the time you will get it as virtual and magnified image. Assume you kept somewhere between F and O. See, all these things, conditions you should know. That is what we have learned from part B of this chapter. Okay, drawing the ray diagram is also very much important. See, in the board exam, they might give you the numericals which you are going to solve, or they will give you ray diagram. Some case, if the paper is little easy, they will give you both the things, okay, ray diagram as well as numerical. So be prepared. Whatever they give, you try to answer. For that, you need to understand the concept. That is what we are doing here. Now anyhow, we got to know anything towards right side, it is positive. Anything towards left side, it is negative. It is from the optic center. Anything it is in upward direction, it is positive. Downward direction, it is negative. This much you should know. Now I'll give you an example. Assume you have placed an object between F and O in front of a convex lens. Okay, convex lens. Then you will get the image here. Okay, you will get the virtual image and magnified. Okay, now see, from the optic center. What is u? What is u? U is object distance. Where is the object? This is object, correct? So how can you differentiate between object and image? Very simple. Without dash it is object, okay, see, and with dash it is image. Anyhow, head and head are in the same direction, so I did not change the b. I did not write b dash and a dash. It is not inverted, it is upright, correct, or erect. So that's why I am using a dash and b dash, not b dash and a dash. Now what is object distance? From the optic center to the object, it is in this direction, correct? From the optic center to the object, it is in this direction, correct? It is in this direction. So here now, for now, object distance u is negative. U is negative. Next, where is the image? This is the image. Image distance also is calculated from the optic center. From the optic center, see, from the optic center till the image, this is the image, correct? So again it is towards the left side. Image distance is also negative. For this example, both are negative. How can we say both are negative? All the distances are calculated from the optic center, only these three. I and O I'll teach you later. So about focal length, I'll give you clarity. Very simple. For convex lens and concave lens, it is completely fixed. Okay, it is fixed. There is no need to change anything. While finalizing, I'll give you the values for whether it is positive or negative for what lens. Okay, now we'll talk about height. Okay, now listen. I told you height of the image. Height of the image is nothing but, and after object height, both, okay, will be always considered from the principal axis. If you see, this is the height of the image. See, this is the image distance. This is the image height. So if it is in upward direction, we learned it is positive. So here image height is positive. Why it is positive? Because the image is upright or erect, it is facing upward direction. If the image was real and inverted, it would have been negative. Now image height is done, then object height. So now listen, object height. See, this is the object height is this much, and it is again facing. Object height is always positive, keep this in mind. See, object distance is always negative because we are keeping on the left side, object distance. So if always we keep the object here, correct, and always object distance is nothing but optic center to the object is always towards left. So object distance is always negative. Object height, it is always positive. Why it is object height is positive? Because it is always facing upward direction. Okay, keep these two in mind. Finally, I'm going to tell you, don't worry about it. For now, for this example, these are the things. Don't worry about focal length. It is completely fixed for different lengths. Okay, I will tell you at the end whenever we are talking about the conclusion part. Now, so for this example, these are the values. Whenever you get silly doubt, okay, just rewind back and watch it. You will definitely get it. You should know the reason. Towards right positive, towards left negative, to upward positive, downward negative. Now we'll talk about the real image. Assume real image is always obtained on the right side. Real images are always obtained on the right side and it is always inverted. Okay, virtual image. In the previous case, we found the image was here, right? So that was virtual image. Now realism. Only two types of images are possible. So if we learn both, then aramse we can understand any question. Okay, any sign convention. Why sign conventions are important? They are not going to ask questions based on these diagrams. You are going to use it in numericals. They may ask you any logical questions also. If you know the concept, you can answer any question. Now assume we have a this one inverted, real and inverted image. Don't worry about the height. We are not looking for the values. We are looking for the sign, whether it is plus or minus. Next, so first we'll go one by one. Object distance. This is object. So what is object distance? From the optic center to the object. So without checking, you always write object distance is always negative. Object distance is always negative, whether it is for convex lens or convex lens. For both the lenses, object distance is always negative. Why? Because object is always kept on the left side. Okay, and what is object distance? From the optic center to the object, it is in towards left. That is why it is always negative. Next, image distance. Where is the image? So if this is AB, this is the head, right? This is the head, so this will be A dash and this will be B dash. Now image distance, this is the image. What is image distance? All the three, U, V, F, all the three calculated from the optic center. Optic center, so from the optic center to the image, it is towards right side, it is towards right side, so image distance is positive. If it is towards right side, it is positive. Next, focal length I'll tell you later. Next, image height. Where is the image? This is the image. Image height is downward, facing downward direction, correct? If it is real, it will always be facing downward, so image height will be negative because it is facing down. Object height, I told you object height is always positive because it will be always in upward direction. So with the possible examples, we have found the values. Now we are going to conclude it. Very simple. Now object distance, see, object distance is always negative, is always negative. Object distance is always negative. Image distance, it is negative for virtual image, and it is positive for real image. Okay, see, real images are always found on the other side, correct? Real images are always found the other side. So if it is found on the right side, what is this one? Image distance from the optic center to the image, it is always towards right. That is why for real image, okay, real image means it is, if it is downward direction, okay, that is real image. For a real image, okay, it is always positive. For a virtual image means you will get the image somewhere here. Okay, this is not about any lens. This is for both the lenses. Okay, this works fine with both the lenses. We can aramse follow it. Next, focal length. I told you I'm going to conclude it with the lens. See, for it is positive for convex lens. It is positive whenever they say convex lens or converging lens. Sometimes instead of using convex lens, they'll use converging lens. For convex or converging lens, it is always positive, and it is negative for concave. Okay, next, image height. Image height, it is negative. Okay, it is negative if the image is real. If it is real, what happens? It will be always upside down. Anything towards downward direction, it is always negative. That is what we have learned. Next, this will be positive, it is for virtual images. Next, object height is always positive. Always. Why? Because object height means from the principal axis to till this one, so it is in upward direction. Object height is always positive. Object distance is always negative for both the lenses. So this is also for both the lens, this is also for both the lens. So this is the sign convention. If you know this concept, aramse we can solve all the numericals. Till now we have understood the sign convention of lenses. So this is about mirrors. When it comes to mirrors, the concept remains same. Towards left side, okay, it is negative. Towards right side, it is positive. Upside positive, down negative. All those things remain same. But here when it comes to mirrors, we know the real images cannot be obtained on the right side. It will be on the left side for mirrors, because after the intersection they are going to meet, correct? So now U will always be negative, okay, for both the mirrors. For both the mirrors, U is always negative. Next, V will be negative if it is real. How? But in lenses, V was positive for real, right? Because if it is okay, real image for lenses, it will be forming on that side, on the other side of the lens. But when it comes to mirrors, okay, after the reflection, they come back to the same medium. The rays will intersect on the same medium, on the towards left. That's why towards left, anything towards left is negative, right? And virtual will be behind the mirror, so that side, so it will be towards right side, it will be positive. See, focal length in lens and mirror, it will be fixed for different lenses. So here also for mirrors, it will be negative. Whenever you get to know it is concave mirror, okay, it is always negative, and if it is convex mirror, it is always positive. Next, I. See, I means height of the image. See, in CBSE, I will be taken as H dash. O will be taken as H. So here in ICSE, I represents height of the image. O represents height of the object. We know height of the image they can give, or size of the image they can give, or they can tell you the length of the image also. Whenever they tell length of the image, you have to take it as height of the image or size of the image only. So here, even though okay, in mirrors it is always negative if it is real, because if it is real it is always inverted. Anything towards downward direction it is negative, and positive if it is virtual, because it is erect. Next, O means object height. It is always positive for both the mirrors. So this is about the sign conventions for both lens and mirror. First we understood the lens, correct? And while understanding the lens, we understood why we have to take positive, why we have to take negative. At the end, we just furnished only about the mirrors. So complete sign convention for mirrors. If you know this much, any numerical, okay, whether it comes to lens or mirrors, you can aram se solve. Thank you.